Alright, so what we want to do in this video is we want to actually um, we want to do um, a problem on implicit differentiation. So implicit Okay, so the problem that I want to look at is I have x times y equals equals y squared plus x squared. And suppose that y is a function of x. So suppose y is given implicitly as a function of x. And now they want me to find dy. They're asking me to find dy. Okay, so they're asking for dy. Dx. So let's see how we're going to do this. So here we have a situation where we have here a product, here we have a sum. So let's see what we're going to do. So we're going to multiply both sides of this expression given here by d dx. Actually, let me do this in another color because it will probably be more interesting and better remembered. So I'm going to be working in red. So I go d dx for both sides, x times y equals d dx of x, of y squared plus x squared. Let's see what this becomes. Okay, so let's see. So this is going to become, now we use the product rule here, so this is going to become x prime times y plus x times y prime. Of course here x prime is equal to d dx of x and y prime is equal to dy dx. And of course this is going to be equal to the derivative of this, which is equal to 2y times dy dx. But I said that was y prime, so I'm just putting the y prime here. And then plus the derivative of this with respect to x, so it's going to be equal to 2 times x. So x prime dx dx is just going to be 1. So this is going to be equal to 1 times y. So y plus x times the derivative of this, well, that's just going to become dy dx. So here I have that this is equal to 2y, okay, dy dx plus 2x. Now they're asking me to solve to find dy dx. So what this translates into is that I have to solve for dy dx. So I have here x dy dx, 2y dy dx. I'm going to put everything on this in this side over here. All the expressions involving dy dx, all the terms will be placed on this side. So let me move this y over to this side over here. Okay, so this implies here, right? This implies that x dy dx All right. Minus, I'm adding negative 2y dy dx to both sides, minus 2y dy dx is going to be equal to 2x, and I am adding a minus y on this side. Okay, so now what I'm going to do is I am going to factor dy dx from the left, and I am going to then conduct myself in an algebraically faithful fashion and solve for dy dx. So let's see what this is going to become. This becomes dy dx times x minus 2y equals, okay, 2x minus y. So now I divide both sides by x minus 2y, and I will have that dy dx is equal, okay, so let me actually, so this is in a dy dx is equal to 2x minus y divided by x minus 2y. So that is what your derivative dy dx is. Okay, the derivative of y with respect to x is equal to that. Let me actually make this look a little bit better, because at this juncture it does not look that great. Okay, so let me actually, so that's dy, and this is dx here, is equal to this, and of course I'm going to box this in so that it looks final here. Okay, here it is. It doesn't box in nicely, so I will probably skip that part. Okay, so this is dy dx. This is dy dx. Thank you for listening.